This lesson covers exponential notation, also called scientific notation. Once again, this is very, very critical you understand this as we're dealing with science, because or in chemistry especially, because we're going to work with very large numbers and we're going to work with very small numbers. So scientific notation makes it very easy. Commonly work with this a lot, and it's also important you understand it for sig figs. First of all, let's look at Avogadro's number. We're going to work with Avogadro's number later on. I'm not going to explain this, but Avogadro's number is a huge number, and to have to write this out is not realistic to have to put this in your calculator every single time. So what we'll do is we'll place it in scientific notation. Now the rule of thumb is you can only, when you scientific notation, you move your decimal so there's only one non-zero digit to the left of the decimal. As we see in this example of Avogadro's number, you see the 6, and so there's one digit. But we had to move the decimal 23 times to get it over there. So we work with very large numbers. We also work with very, very small numbers. So you have to understand we're working with the atom. Such an example of breaking the atom down to the electron has a mass. Now I know we look at its mass being negligible, but it actually has mass, so it is matter. But we look at this number and we see how small it is, and to put this in our calculator once again is non-realistic. So I want to move it all the way over so only the 9 is to the left of the decimal, and all I have to do here, really, really easy, is just count the zeros and the 9, and I count that number all the way over, there'll be 31. Now, since I'm starting out with a number very, very small, however, my 31 spaces are actually going to be negative, telling me that my number is very, very, very small in that process. So the technique is this. Basically, rule of thumb is the one non-zero digit to the left of the decimal. When the decimal is moved to the left, the exponent then is going to be positive, as like we see with example number 1 with Avogadro's number. We move it to the left to get to our goal, represents it's actually a large number. If we move it to the right, like we saw in example number 2, the mass of electron, then we had to move it to the right because the number was so small. Therefore, my exponent is negative, representing a very small number. The actual number and the value given to you up there, both of those are called positional notation. What I gave you an example of is changing them to scientific notation. So the number positional number when changed to scientific notation, you must maintain the correct number of sig figs in that actual number. Don't change that number of sig figs at all. So Avogadro's number had 6, the 0 is sandwiched in the 2, so it's 4 sig figs, and my mass of electron 911 only had 3 sig figs. So we practiced this in class. We saw that the 135,000. I wanted only 3 sig figs in this situation, so in this situation I'm going to move a decimal to the left, and I'm going to count the 0, the 3 zeros, which is 3. The 5 gives me 4, and the 3 gives me 5. So it's 10 to the 5th. I had to move it 2 places, but I'm going to keep the 1.35 and it's 10 to the 5th. The next one is a very small number, so I know my exponent's going to be negative. Again, I'm going to move my decimal to the right. I want my decimal to fall between 2 5s, so to move it over, it's the 2 zeros and 1 5, so it's 3 places, it's the negative 3. For the next number, I want only 2 sig figs, so I'm going to keep the 1 and the 2, and I need to move it to the left to get over there. So this is with the commas, easy to follow. I have 3, 6, 9, and then I have 2 more, so it's 11. So 1.2 times 10 to the 11th. And then going from that last one's a very small number. Now we move my decimal to the right, so now I know my exponent is going to be negative value. And I realize I am moving it, I have 7 zeros and then one of the 4s, because I want it behind that 1 4. So 8, so it's a negative 8. The next thing is very, very important you understand how to put this in your calculator, and this is how each calculator is going to be slightly different, and this is where we're practicing class. Make sure you understand it. If you have difficulty doing this, please let me know, because you need to understand your calculator. This is also important why you should have your own basic scientific calculator used on the test, because you'll be expected to do this on a test, and each calculator tends to have its own order of operation. So commonly what you'll do is you'll enter the actual whole number, then you'll press the exponent key, which is commonly E or EXP, could be 10 to the superscript X. I've seen 10 to the superscript N. but you're going to push that key. Then you're going to enter in the actual exponent, which in this situation is my negative 19. Now for the negative key, some calculators want you put 19, then make it negative. Other calculators want you to make sure it's negative, then the 19 you enter first. But that's really kind of up to your calculator. So make sure you understand how to enter a number, a scientific notation number, actually in your calculator. Then we did some math. And the math now is very, very important. And this is something critical we have to practice with. And this is where is going to save you a lot of time once you understand it. What you always do when you have numbers in your numerator and denominator, the rule of thumb is this with a basic scientific calculator. Now this is not the same for a programmable calculator. This is your basic scientific calculator. It's fundamental. Make sure you understand it. All you're going to do is you multiply across the top. All the numbers. You keep on just multiplying all the numbers across the top until you're done. Then you're going to push your division key and you keep on dividing across the bottom. For example, I'll go to number 2, which throws people off. I'll go 1.76 times 10 to the negative 2 times 4.2 times 10 to the negative 4 divided by 6.99 times 10 to the 6 divided by 8 times 10 to the 14. So I divide by each number in the denominator as if it were its own division problem. Even though it's set up being my 6.99 times 10 to the 6 and my 8 is actually showing mathematically that it's multiplied by your 8 times 10 to the 14, that's not how your basic scientific calculator thinks. So really make sure you understand that rule. And then we went on to understanding how to raise a power. This is your exponent. This is very, very important how to raise things. A lot of your calculators use a TP key, so X with a TP key, or X to the Y, or Y to the X. And this is one of those things you'll need to practice with. And I'll give you the answers there. Also taking the root of something. By default, common calculators at least have by default square root, but if it's anything greater than that, then you actually have to understand the format of it. So it's very, very important you understand that. Examples again for scientific notation. If we have a larger number, a number greater than 1, we want to put it in scientific notation. Remember, I want 1 digit to the right of a decimal. I'll be moving my decimal to the left because it's greater than 1. In this situation, I move it 2 places. I have to move it past the 8 and the 6, so it's 10 to the second. If it's a small number, now I'm moving back to the right because I want my decimal to fall between the 7s, and therefore I know now it's going to be a negative number. So I just count my zeros, which I have 5 of them, and then I'll go past one of the 7s, so it's a total of 6. So it's 10 to the negative 6 in that situation. In addition to subtraction now, as we're working with these decimals, in addition to subtraction, and this is, we really won't do this a whole lot in our math, but it's helpful to know you won't have to do this so much because you do have your calculator. But if you don't have your calculator and you have to do this, the key is this: make the exponents the same. So in this situation, I'm making both 10 to the 4th, and now what I'll do is just add the numbers, and it will be 10 to the 4th, and I will adjust it in proper scientific notation if need be. For addition and subtraction, though, this is helpful because multiplication division, is helpful because the multiplication division, we will use this in the metric system because everything's going to be understood 1, which is very, very helpful. So in this one, though, the rule of thumb is you're going to add, when you're multiplying, you add your exponents. And then when you divide, you subtract your exponents. Make sure you put that to memory. Very, very helpful. It's going to pay off when we get to move on to the metric system.